So last time we made a frequency table. We turned that table into a histogram. And we answered questions about the histogram. But one thing that both the table and the histogram show us is a shape that the data has. And it's easier to see in the histogram than in the table, but you can also see it in the table. We're interested in four generic shapes. So you need to know how to identify these four shapes. So the first one is called uniform. If you have a uniform distribution, all the frequencies or relative frequencies are going to be about the same. They may not be perfectly equal, but theoretically we're going to say that they're all exactly the same. So every class would have the same frequency or same relative frequency. Normal distribution. So the normal distribution, your highest frequencies are in the middle, and then it drops off on either side. That's how our distribution looked on our histogram that we made. And then if you have that same general normal distribution that's symmetrical for the most part, but say one tail is longer than the other one. So if you have a longer right tail, that's called skewed to the right. We say that data is skewed. And if the tail on the left is longer, we call that skewed left. It doesn't have to look like a normal. Anytime one tail is longer than the other one, you say that the data is skewed. So let's look at some examples. Let's start with the second two. Might be easier to start with those. So the last one, this is the number on the face of a die. If you roll a six-sided die, it's got six faces on it. You record the die that's facing up when the die comes to rest. All of these have the same chance of happening. They'll have the same frequency. So it's just called uniform. Yes. Yes, give me 1 second. I gave you a windowed screen this time because I need you to use your computers in just a second. Okay. So go ahead and log in if you haven't logged in, and get into MyLabs Plus. But we'll continue. So uniform means all the frequencies are about the same. You get kind of a flat line. In this example, you see the tail on the left is longer than the tail on the right. Yes. So we'll just give it a minute. So if the tail on the left is longer, it's skewed left. In this example, it doesn't even have a left tail. So the tail on the right is definitely longer. This one's skewed to the right. Then the first example, it's not perfect, but it's roughly symmetrical. The highest frequencies are in the middle, and then it drops off on either side. That's called normal or bell-shaped. Have you ever heard of the bell curve? That's what we're talking about. So if we drew a line over the tops of the bar graphs, drew a line over the tops of the bars, it would look like a bell, right, sitting on a table. If you're looking at it from the side. So that's why it's called a bell-shaped curve. Right, true or false? This distribution is skewed to the right. True or false? This distribution is skewed to the right. Right? Most of you say true. Correct answer is true. So sometimes it's confusing because most of your data is to the left, but it's because the tail is longer on the right side. We say skewed to the right. And the skewness happens because most of your data is in the 18 to 38 range, say. These really high values, the 48s, 53s, and 58s, those in that range are skewing the data. Okay, they're unusually high. Most of the data is between 18 and 38. These really high numbers are skewing it. Okay, so that's why it's called skewed to the right. Any questions about that? Okay, so I'm going to release your screens. I need you to log in. I need you to get into MyLabs Plus. And there is a tab on the left called StatCrunch. I want you to find that tab and get to this page. So you need to log into the computer. It might take a minute. Go into eLearn. Or you can sign in directly through MyLabs if you know how to do that. Maybe we should talk about that. If for some reason, say eLearn is down, you can go to Chattanooga State. .mylabsplus.com. The username is your A number. So it's not the same as your TigerWeb logins. The password is chatstate, one word, lowercase, unless you've changed it. You might have changed it already, or you might have changed it in another class. So you can get through eLearn through that link, or you can go to that website and use that username and password. eLearn was down yesterday in the morning, like before 8 o'clock. I didn't think it was a big deal, but if it was ever down when you needed to do your homework, then you can go to MyLabs directly. Are you with me? Okay. So we're going to click on this link called StatCrunch website. And we get this page. We will use this page some. This is how I'm going to share with you the data sets in your project. And we'll use it for other things too. But for now, we're just going to say open StatCrunch, this link at the top. and you get a blank StatCrunch page. So StatCrunch tab in MyLabs Plus, StatCrunch website, that brings up this page. You click Open StatCrunch and you get a blank spreadsheet. It's like an Excel spreadsheet. So we're going to take that data that we've been using. Let's see if I have a copy here. We're going to take the data from Bobak's restaurant, those 40 consecutive Saturdays. They counted how many students were there. Oh, I didn't print those off. I just have to go split screen here. This data that we used on Tuesday, we're going to type that into one column in StatCrunch. So we're just going to put it all under variable 1. It doesn't matter what order you type them in. You can go by column or by row, as long as all the data values are in there. This is on your notes, so you should, if you printed this off, it should be easy to put it in. You should have 40, and you should go through and check them. After you type them in, check them. See if you typed them in correctly. If you need help, I'll come help you. So just make sure it's all in one column and make sure that they're all correct. Everybody ready? Oh, you're not done yet? Okay. We will do this a lot in class, so make sure you got those notes printed so you can easily read off the data and type it in. Okay, so make sure you print the notes for class. Just be easier on you. Okay. So it's all in one column. It's called variable 1. If you wanted to rename it, you can click at the column heading and you can name it something else. If you want to call it customers or something different, you don't have to. It's just something you can do if it helps you keep track of what you're doing. That helps if you have multiple columns of data. Now, if you've got 20 columns of data, you need a way to know which column is what, okay? All right, so first thing we're going to do is make a frequency table. So I'm going to go to Stat, Tables, frequency. And I get this, it's a menu here. It's almost like a calculator. And I have to select the column that I want to use. So if you have multiple columns of data, you have to tell StatCrunch which column you're going to make the table for. So I'm going to click Customers. I'm going to leave everything else alone. I'm just going to click Compute and see what happens. So what did it do? Any number that repeated, it counted how many times it repeated, it put them in order, and it also calculated the relative frequency. It divided by 40 on all of these. Now, what's wrong with it? This is not the table that we made. The table that we made had classes. This was 2 to 3 and 4 to 5 and so forth, right? So you could use this to make that table if you wanted to just go through and count them. But for instance, if none of your values repeat, this doesn't really help you that much, okay, if you have those classes. So we need to figure out how to make the classes and then make the frequency table on the classes. So this is the part that gets students, okay? So make sure that you can do this. We're going to go to the data menu at the top. And we're going to select bin, B-I-N. So in StatCrunch, bin equals class. So I called them classes in the table. StatCrunch calls them bins. Okay, so we're going to bin our data. So this is going to assign a class to each data value. So I'm going to click bin. I'm going to pick the column I want to do this to. So it's my first column, the customer's column, or variable 1 if you didn't do anything to that. And I want to tell it how to make the bins. So I can do it automatically. I can use a fixed width bin. That's what we want to do because we want our class width to be the same all the way through. If you want to use different cutoff points, you can if you don't care about them being the same size. We're going to choose Use Fixed Width Bins. Where did our table start? It started with 2, right? The first class was 2 to 3, so our starting value is 2. What was the bin width? What was the class width? It was 2 also. Our class width was 2, and we started with 2. So we're going to do that first. And we're going to leave this bin edges to include the left endpoint. That's how we did our table and our graph last time. So we're going to compute. And the only thing that happened is it creates a new column and it tells you which class each data member belongs to. Okay? It tells you which class each data member belongs to. So how does that help? Well, we want to count the classes instead of just counting the individual data members. So we're going to go back to Stat, Tables, Frequency, and I'm going to choose the binned column instead of the original column. And now it's going to count the classes instead of just the data values. I click Compute. I get the table that we made on Tuesday, except there's one little difference. Do you see what the difference is? Right. So that says 2 to 4. When we made our table, we said 2 to 3, right? But we said to include the left endpoint, not the right one. So what this means is it's 2, including 2, up to 4, not including 4. When you get to 4, you move on to the next class. Right? The next one's 4 to 6. It's calculating exactly the same way, but the classes aren't written the same way that we write them because StatCrunch doesn't know how. Okay? So it's 2 up to 4, but not 4. if your data is, our data was to 1 decimal place, so 3 was the biggest number possible in the first class. Okay, any whole number bigger than 3 has got to be 4, and that would be in the next class. But if your data was to 2 decimal places, say, if your data is to 2 decimal places, like it's weight of a penny or something like that, then the biggest number in the first class is not just 3, it could be 3.99, right? And you would write your class that way. So you would say 2 to 3.99 if your data is rounded to 2 decimal places. So 3.99 is the biggest number to 2 decimal places that could be in the first class. And then when you get to 4, you move on to the next class. Does that make sense? And StatCrunch just can't do this easily. Okay, it doesn't have a program in it that checks your data to see how many decimal places it's rounded to. So it just says, well, we'll just go up to the start of the next class, and you just have to know that that's what that means. In your homework, you have to come up with that number. Okay, it's just based on your data, how many decimal places your data is rounded to. So the next class would be 4 to 5.99, right, if your data is rounded to 2 decimal places. Here, our data is all rounded to the nearest whole number. It's actually, they're not even rounded, right? They're just whole numbers because it's discrete. So 3 is the biggest whole number, less than 4, greater than 2, right? But the good part is it gets all this correct, right? And that was the tedious part. You don't have to count through and mark off the data points. So how did we do all that? We went to data, bin. We chose a column and we told it how to make the bins. We chose a starting point and we chose a class width. StatCrunch calls it bin width. Okay, and it creates a binned column. And then we did the frequency table on that binned column, and it counted up the classes for us instead of just counting the individual data values that repeat. Are there any questions about that? That's hard to remember. It's going to be hard to remember a couple of weeks from now. But just make sure that, before the next class, you need to have tried this, go over your notes. I've listed out the steps in StatCrunch in your notes. Okay, it's listed there for you step by step. There's also a StatCrunch guide in the course information page that's got screenshots in it that you can go along with. So make sure you know how to do this. Otherwise, you're going to be on the test counting individual data members in the data set and trying to just count them up by hand. Okay. Okay. So the next thing we did was we made a histogram. So a histogram is a graph, so it's going to be under graph. So graph menu, histogram. So we want to pick the column we want to do this with. This only works with raw data, okay? You can't have a table already and convert it to another table. You have to have a raw set of data, either a sample or population. You need to have a column of numbers, okay? All right, we can only choose frequency or relative frequency. We can't do them both at the same time. So let's just do frequency for now. And the good thing about this histogram is it lets you define the bins inside the histogram calculator. So we don't have to bin the column before we do this. Okay, we can just do it right here. We're going to start at 2 and have a class width of 2. And let's just click compute. And we get the histogram. Does that look like the histogram we made? Now StatCrunch will choose the scales for you. So I think our scale went up to 20. I think it went 0 to 20 by 2. This one only goes to 12. That's all it has to go. So that's okay. All right. I want to change something about this graph. So instead of doing all that over again, I'm just going to click Options, the top left corner, and Edit. It'll take me back to this screen, and I can change. So one thing I would like to do is display the value above the bar. So I'm going to click this check mark here, Value Above Bar, and Compute, and that will give me the frequencies of each class. You could use this to make your frequency table if you wanted. Okay. If you click on, well, first of all, if you hover over it, it will tell you the frequency and the class that this belongs to. So 8 up to 10, not including 10. And if you click on it, it will highlight all the members of your data that go in that class. Okay. And if you want to get rid of that ugly pink, I don't have anything against pink. That was a joke. At the bottom, you just click clear, and it'll clear it back off. And you can click multiple ones if you want. And then when you get a headache, you clear it. So this is useful if, say, well, there's only one of these in this 14 to 16 range, so let's click that, and then I can find it pretty quickly visually. I can figure out where it's at. Okay, let's click Options and Edit again. We'll change it again. We're going to change it from frequency to relative frequency. So these will be using the relative frequencies instead of just the frequencies. So change it to relative frequency. Click Compute. Hit clear at the bottom left. There you go. Anybody else need help? So first of all, it looks the same, right? Has the same shape. So if you do a relative frequency table or a frequency table with the same classes, the shape will be exactly the same. What's different about this is the vertical scale. So our scale before was 0 to 12. Now it only goes from 0 to 0.3. Right? Relative frequencies have to be between 0 and 1 because percentages can only be from 0% to 100%. Right? 100% is the max. So all these are going to be between 0 and 1. So it's a very small scale vertically, but when you blow it up, it looks the same. It's got the same shape. You read the same information, and the same thing, you can hover over the bar and it'll tell you what it is. And notice this third bar, the value above the bar is 0.23. It's been rounded to 2 decimal places, but you can see it rounded to 3 decimal places if you hover above the bar. If you need 4 decimal places, this ain't going to help you. Okay? This value above bar for relative frequency will not give you 4 decimal places. So you'll have to do it using just the table. And if you wanted to say, I don't know, put this in a document for a project, you could download it. Don't do this. You don't have to do this. I'm just going to show you. I can't open it. Let me show it in a folder. It didn't work. Let's just see if this works. There we go. I put it right inside a Word document. Okay. In your project, that's what I want you to do. I don't want you to draw these things by hand. That would look terrible, right? If I drew it by hand, it would look terrible. So, you're going to use StatCrunch. A lot of your data might have 500, 1,000, 2,000 data points in it. You're not going to be able to do a lot of this by hand on your project. You're going to have to use software to help you. Okay. All right. Any questions about StatCrunch? I made it overlay the normal distribution so you can see how close it is to a perfect normal. So it's decently close. We wouldn't say skewed right or skewed left here. We definitely wouldn't say uniform. So if we had to pick one of those four, for this one, we would pick normal, even though it's not perfect. Things don't usually work perfectly in the real world. Sometimes they do, but not usually. Any questions? So I went to Options, Edit, and under the display options, I chose the normal distribution to overlay. It says overlay distribution. I chose the normal one, and it gave me that. You can also show the mean and median. We're going to talk about that today. It'll show you red lines where the mean and median are. And if your mean and median are real close like that, that's an indication that you have a normal distribution as well. So we're going to do more stuff today, but at this point, after you complete this homework for 2.2, you can do your quiz. Okay, so that's due Monday, and the quiz is due the next day. Okay. Okay. So let's move on to chapter 3. Yeah, we might use it again. Just leave it. I'm gonna take control here, but you might use that in a minute. All right. So chapter 3 is about after we've summarized the data, or after we've organized the data, we want to summarize it. And we summarize it using descriptive statistics. We want to compute things about the data. And the first one is an easy one that you've all done before at some point in your lives. They're called measures of center. So this is called mean, median, and mode. Right? So you've all heard of that before. We may just talk about it a little bit differently than you did before. Okay. So we're going to use some math notation. So this weird-looking E symbol is actually a capital sigma in the Greek alphabet. So this is a Greek letter. Mathematicians have run out of letters, so we have to go to the Greek alphabet. We also use Arabic sometimes. But this is capital sigma, and it stands for the sum. So sigma for sum. If you have two things to add, you just use the plus symbol. You say add this to this using the plus symbol. But if you have a million things to add, we don't want to write a million plus signs. Okay, so we just stick this symbol in front of it and just say add them all up. Okay, does that make sense? So it's just a shorthand to say add them all without having to write plus sign so many times. We use lowercase x as the variable for the individual data values. Lowercase n is the sample size, and uppercase N is the population size. So we're just going to remember that. So the first measure of center, we're trying to measure where is the middle of the data set, where's the center, is the average. Now we're going to not call it the average, we're going to call it the mean. It's actually called the arithmetic mean. There are other types of means, but we're just going to do the arithmetic mean, so we're just going to call it mean from now on. Okay. So the mean is the average, what you would call the average. You calculate it by adding up all the data values and dividing by how many data values there are. Okay, it's a simple average. We're going to call it the mean. But we have two versions of the mean. We have the mean of the sample and we have the mean of the population. And they have different symbols. Okay, so the sample mean, we're going to say X bar. And it's literally an X with a bar on top. So we say X bar. So X bar is a symbol that represents sample mean. And how do you find the sample mean? You add up all the members of the sample and you divide by how many there are, the sample size. How many are in the sample? I don't know, right? So I don't know how many to add up. I just need to say add them all up. So I'm going to use the shorthand sigma x. Add all the x's up, and x's represent the data values. Add all the data values up, divide by the sample size, which is the little n. Okay? So that's the shorthand for how to calculate the average or the mean. Population mean has a Greek symbol, and it's called mu. You say mu, not mu, but mu. Kind of hard to say. And it looks like an M and a U stuck together. Okay? So if an M and mu, or if an M and a U had a baby, this is what it would look like. So it looks like a U with another tail in the front. Okay? And people write it different ways. That's just how I started writing it. So we're going to add up all the individuals in the population and divide by the population size. So that's the shorthand for that. Sorry? Okay. Well, won't do a whole lot of algebra, but we will do some.
Letters.
Yes. Yeah. Well, we'll have formulas, right? I mean, we got to have formulas to calculate things. So we're going to use them. Listed below are the lengths of time in years it took for a random sample of college students to earn bachelor's degrees. Based on these results, what is the mean number of years it takes to earn a bachelor's degree? So we're going to calculate the mean, and this is a sample, right? So we're going to call it X bar. So we're going to add up all the x's, divide by the sample size. So I'm going to use calculator just to do the simple thing. Simple calculations, calculator's just fine. I got to organize myself here. All right, so 4 plus 4 plus 4, 6 times. I could have just said 6 times 4. Maybe I'll do that next. How many 4.5s? So 6 times 4.5. 2 6s, that's 12. An 8, 2 9s is 18. 2 13s is 26, and 15. That saved me a little bit of time there. I get 130. So that's the numerator here, 130. And then how many are there? There are 20, right? So this is divided by 20. So I'm going to divide this number by 20. 6.5 exactly. So 6.5 years. That's the mean number of years it takes to earn a bachelor's degree based on this sample. Everybody okay with that? Okay. The median. The median is the middle value, the value in the middle, when you arrange your data from least to greatest. So you put your data in order. Whichever one is actually in the middle, we call that the median. So we have an example here. In this case, there's an odd number of values. There's 5. We're going to put them in order, so least to greatest. 19, 29, 32, 36, 45. Okay. Is there an exact middle? 32. We pick the middle value. That's the median. Okay. It's pretty easy. This one, there are only 5. The next case, there's an even number of values. So I'm still going to put them in order. Does this have an exact middle value? No. So if there's an even number of values, you don't have an exact middle. But what you want to do is take the middle 2 values, so the end of the first half and the beginning of the second half, okay, and find the average, find the mean of those 2. So we'll want to split those in half, basically. Split the difference, find the midpoint. So 32 plus 35, that's 67, divided by 2 is 33.5. So that's halfway between 32 and 35. So it's going to be the median. So if there's an even number of values, you can't find an exact middle, so you split the difference between the 2 middle values. Okay? Everybody okay with that? So we have a little trick here, an algebra trick. If you have a large data set and you want to quickly find the median, if it's already in order, if the number of observations is odd, the median is going to be in the n plus 1 divided by 2 position. So in our previous example, there's 5 numbers. So that means n is 5. So what's n plus 1 divided by 2? It'll be 5 plus 1, which is what? 6. 6 divided by 2 is 3. That means the median is in the 3rd position. And that's where it is, right? It's in the 3rd position in the data set. So if there's 103 data members, where's the median? Add 1 to 103. It's 104. And we divide it by 2, it's 52, right? So it would be in the 52nd spot when your data is put in order, okay? Okay, if it's even, the number of observations is even, then you take the average between the n over 2 position and then the next one. The next one would be that n over 2 plus another one, right? So in our example, we had 6. What's 6 divided by 2? 3. So we take the average of the third and fourth positions, right? N over 2 plus 1 would be the 3 plus 1, right? So in this previous example, this is the third position, this is the fourth position. We take the average of those two. Right, so let's do this with our bachelor's degree data. How many are in the data? 20. That's even. So I know I'm going to have to average two numbers. Where am I going to average? Which two numbers am I going to add together? The n over 2 position, which would be 20 divided by 2, is 10. And the next one, so the 10th and 11th positions. Right? Does that make sense that it's 10 and 11 when it's 20 numbers? Yeah. Right? It's the end of the first half and the beginning of the second half. So let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 11 is right here. We need the average. What's the average of 4.5 and 4.5? 4.5, right? Add them together, you get 9. Divided by 2, you get 4.5 again. Right, so here, the median is 4.5. Sorry? Any questions? We got a mean of 6.5 and a median of 4.5. Which one do you think is a better representation of the typical number of years it takes to earn a bachelor's degree? 4.5 or 6.5? The 4.5, right? 4.5 is more typical. But the 6.5 was the average. So why was the average a lot bigger than the median? Yeah. Say it again. Right. So the mean uses every number and even these really big numbers, okay? And that pulled the mean up. It skewed the mean, okay? But if I change this 15 to 150 years, the median doesn't care. The median's the same either way, right? But this would make the mean a lot bigger, okay? So when you have these extreme values, the median is resistant to those values. So, we would probably rather use the median. So if we were to calculate our median income in this class and the average income, they might be about the same numbers. But if LeBron James walked in, our mean would jump a lot. Our mean would probably multiply by 10, But the median would not change that much. The median would be about the same as it was before. Does that make sense? So that's how we choose, which one do we use, mean or median? They're both measuring the middle. It's what are you looking for? Are you looking for the average? Then use the average. If you're looking for what's the best representative of a typical data member, it could be the mean, but it could also be the median. All right. Next is the mode. The mode is the data value with the greatest frequency. It's just the one that occurs the most times. So there has to be at least one value that repeats in order to have a mode. So if all your numbers are different, then you just don't have a mode. You just say no mode exists if all your data are unique. If there is a tie for the most frequent, you can have multiple modes. If there's a tie for first place, then you can have multiple modes. And you use the mode for qualitative data. If I asked you what state you live in, and you tell me Tennessee and Georgia, maybe Alabama, I can't add those up and find the average. I can't find the median. Okay, median is not an alphabetical order; it's a numeric order, and they're not numeric, right? But what I can do is count how many people live in Tennessee, and count how many people live in Georgia, and count how many people live in Alabama, and I can come up with a mode for a qualitative data set. Okay, so this is a way to calculate the center, if there is a center, of qualitative data. You don't normally use this for quantitative data. You usually use mean or median, but really any good statistician is going to tell you all these things anyway. So you can look at them and see which you think are the best. So we're going to count how many repeaters we have. So there are 6 4s. There are 6 4.5s, 2 6s, 2 9s, and 2 13s. So those are our options for the mode. There's a tie for first place. So we would say modes are 4 and 4.5. Okay, there are 2 modes. And both of those actually are better representations of a typical number of years it takes to earn a bachelor's degree than the mean was. We're used to calculating averages, and we're going to calculate averages a lot in this class. But we also need to recognize that you have alternatives. Okay, you have alternatives, especially if you have extreme data values. You know, data values are really far away from the rest. Okay. I'm going to release your screen just in case you need to use a calculator. It's fine if you want to use a calculator. But we have a data set. This is the length in minutes of a sample of cell phone calls. And let's just find the mean. And there is a 6 up here. And then it goes down to the next line. So 6, 19, 3, 6, 12, and 8. I should have put commas in between them, but I did. So 6, 19, 3, 6, 12, and 8. I guess I should know what the answer is, so I better do it myself. Okay. The answer is up there. So we have 85% think it's 9 and 14% think it's 6. So when I added them together, I got 54. And there are 6 data values. So 54 divided by 6 is 9. So 9 is correct. Okay. Same, or might be a different data set, but find the median of this data set. So 6, 9, 3, 6, 12, 8. What's the median? So you got to write them in order. We are a little bit behind. Part of the reason is I've added these questions in that I'm asking you. You think we should keep doing this? You like this? Okay. We will keep doing it. Good, because I've already written a lot of questions. And I'd like to use them. Okay. Just know that the due dates are going to have to change because I didn't factor this in when I kind of did this at the last minute, so I think it's good. So most of you say 7. So if you write them in order, there's 6 values. The middle 2 are the third and fourth values. Take the average. 8 plus 6 is 14. 14 divided by 2 is 7. Also 7 is halfway between 6 and 8. So that's the median. The median is 7. Okay. Questions? You got it? Okay. All right, let's go to the next one. Everybody's getting them right now. All right, what is the mode? Yeah, so I think everybody agrees. It's 6. So it's the only one that repeats, so it's automatically the mode. Right? If it's the only one that repeats, then it has the highest frequency by default. It repeated twice, so the mode is 6. All right, good. Okay. So how about we put this in StatCrunch and we'll kill 2 birds with 1 stone here. Do you have your screens already? Okay. So open up StatCrunch. You can use the same sheet that you had before. You're just going to type in the number of patients at different hospitals. So this is number of patients admitted per year for severe asthma at 8 different hospitals. We're going to compute the mean and median. I'll show you how to do it in StatCrunch, even though this wouldn't be too hard to do with a calculator and with pencil and paper. Yeah. No. You can save it yourself. You can click Data, Save, and you can save it to your StatCrunch account. And you can open it back up, but it won't just save on its own. And any kind of graphs you make, you can save those as well if you want. Okay, so to compute the mean, median, and StatCrunch, we're going to select Stat, Summary Stats. These are statistics that summarize the data. We're going to choose columns because that's how we've got our data organized. We've got them organized in columns. We're going to choose the column that contains the data that has the hospital customers or hospital patients in it. So for me, that was just variable 3. I didn't change the name of the title. And I'm just going to click compute because mean and median are defaulted in this calculator. So the summary stats calculator has some default things that it gives you. It tells you how many there are. It calculates the mean. It calculates some other things that we'll learn. And here is the median, 10.5. So the mean is 71.6. The median is 10.5. If we wanted to find the mode, what would we have to do? We can count them, but what if there were 100,000 of these? So it's not one of your defaults, but you can just simply make a frequency table like we did earlier, and it'll tell you which one occurs most frequently. You can see which one's the highest. So here it's 10, right? 10 would be the mode if we were asking for the mode. So the question says, which measure of center better describes the number of patients admitted per year for severe asthma at a typical hospital? Which one's better? The mean or the median? The median. Why? Because that 500, right? The 500 skews the data, skews the mean to the right. So the 500 is an extreme value, okay, and it's going to pull the mean away from typical. Why do you think that? Why do you think that 500 is in there and it's so much different than the others? What's a possible explanation? It could be in an area that's got bad air, poor quality air. It could be a large hospital in a big population center. It could be a hospital that specializes in asthma, right? It could be a data entry error, right? Somebody meant to type something else. They typed 500, or they looked at the wrong number when they were typing, or something like that. So it could be any of those things. We don't know. So the median kind of helps you deal with that kind of thing. If you use the median, you don't have to worry about those data entry errors, because you're going to just assume that you're not going to have many of those. Okay. I'm going to show my screen for this. A numerical summary of data is said to be resistant if extreme values, either large or small, relative to the data, do not affect its value substantially. So we say the median is resistant to extreme values. The mean is not. The mean is very susceptible to extreme values, okay? Because you're adding up all the data and dividing by the total number. So you can tell something about the mean and median based on the shape of your histogram. The shape of your data will tell you the relationship between the mean and median. So if you have, let's look at the one in the middle. If you have something that's roughly symmetrical, roughly normal, then your mean and median will be about the same. They don't have to be exactly the same, but they're going to be roughly the same. If you have perfect symmetry, perfect normal distribution, or bell-shaped distribution, they will be exactly the same. Okay. All right. Let's look at the one on the right. Most of my data is to the right. If I cut off the tail, it would look like a normal distribution, right? But it has this long tail to the left. They are infrequent, but they are really, really small. And they are extremely small relative to the rest of the data. The rest of the data is here. The rest of the data is here. And these are extremely small comparatively. Even though they have small frequencies, the hot to the bars are the frequencies, how many there are. Just one or just a few of those extreme values can make a difference. So these extreme values are going to pull the mean down, right, instead of up. The 500 in the previous example pulled the mean up. These small values are going to pull the mean down, but the median is going to stay about where it would be anyway. So the median is going to be about here, and it's going to be greater than the mean. And the mean will be somewhere else. It'll be pulled to the left. Okay, the mean will be pulled to the left. And if your data is skewed to the right, what does that mean? That means you have extreme values to the right. It's going to pull the mean up, like that 500 did in our hospital example. And the mean will be greater than the median. So if you calculate the mean and median, if you compare those two, if they're relatively the same, then your data might be, doesn't have to be, but it might be symmetrical. But if the mean is a lot greater than the median or a lot less than the median, then that's an indication that your data is skewed and you have extreme values. We're going to call those outliers too. We'll have a definition of what an outlier is. But for now, we're just going to say extreme values. Let's see, I don't know if I have a question for that. Let's see. All right, we'll just stop there. I think we're good. Make sure you log out.